Okay, today let me offer you the clues and tools to finding the missing variable up here in this function across here, and the missing variables are A, B, and C. So what are the clues in this question? The first clue is we know that there's a stationary point when x equals 3, and the second clue is we know that there's an inflection point at the point 1, 4. What we're going to do is we're going to use systems of equations and solve them simultaneously in order for us to find A, B, and C. It's that easy. So let's start off with the first clue, and let me just reveal it to you again. And there's a stationary point at x equals 3. Now, isn't it true, and wouldn't you agree, that when we have a stationary point, it means that the first derivative equals 0. So all you have to do is take this function, find the first derivative, make it equal 0. Then just slot the x equals 3 into that to form an equation. So let's do that. So getting the first derivative, we're about to differentiate this one here. We're going to get dy dx, or f dash of x. Let's do f prime of x. F prime of x equals, as we differentiate that, it's going to be 3x squared plus 2ax plus b. Now, isn't it true, as I said earlier, that a stationary point means f prime x equals 0? So we're going to make it equal 0 in order for us to slot and substitute x equals 3 into that equation. So let's make it equal 0. There we go. So let's substitute x equals 3 into that. Let's drag it into there, slot and substitute. So it's going to be 3 squared, let's put the 3 in there, plus 2a times 3 plus b equals 0. Okay, solving this and simplifying it even further, we can, 3 3s are 9 times 3 is 27. 27 plus 2 3s are 6a plus b equals 0. Now that is an equation. We have only two unknowns in that. So let's mark them out. We don't know what A and B is. Now we're going to use the other clues in the question to find out possibly one of them. So how do we do this now? Well, we'll leave that and we can call that equation 1. So let's call that equation 1. Let's go to the next clue. And the next clue, as I said, was there's an inflection point at the point 1, 4. So let's reveal this for you. Inflection point 1, 4, as you can see up there. Now, what does inflection point mean? It means the second derivative equals what? It equals 0. That's right. So let's do the second derivative here. So the first derivative is here. So second derivative, f double dash x must equal, that's going to become, if I differentiate that, 2 3s are 6. So that's going to become 6x, and then we've got 2ax, so that's just going to be 2a plus 2a. There's our second derivative. Now, for an inflection point, what does the second derivative usually equal? It equals 0, doesn't it? So we're going to make that equals 0. So let me write that down here. Equals 0 for an inflection point. Okay, now, what do we have? Well, we have an x value, and I'll label them up. An x value of 1. That's actually the y, the 4. So the x value is 1 at x equals 1. So all we have to do is take that and slot it into that. So let's put x equals 1 into that. So f double dash of 1 equals 6 times 1 plus 2a equals 0. Let's solve for that. And that's going to equal 6 times 1 is 6 plus 2a equals, let's put a 0 here. So we've got 6 plus 2a equals 0. That's f double prime of 1 right over there. So now we've only got one unknown, so it's going to be easy to work out what a is. So let's move the 6 over to the other side, meaning that we're going to have 2a equals -6. So we subtract 6 from both sides. So we get negative 6 on this side. And then divide both sides by 2, that easy. So a is going to equal negative 3. So we have one value. We've got one variable, and we've got it. Okay, we've got the a now. Since we got the a here, we could kind of take that and slot it into there, couldn't we? But we'll still have the b as unknown, and we can work out the b, couldn't we? So let's do that. Let's substitute it back in there. So let's take that and put it into 1. So let's work it out. So it's going to be 27 plus 6 times negative 3. I'll just put negative 3 there, plus b equals 0. So now we've only got one unknown, which means we can solve it, which is pretty cool. So it's 27, 3 6s are 18, take away 18, plus b equals 0. So 27 take away 18, that's going to give us a grand total of 9. So 9 plus b equals 0. Therefore, we know that b is going to equal to negative 9. So there we go. We've got another variable there. We've got b equals negative 9. But you know what? We still don't know what c is. We don't know what it is. So how are we going to find what c is? Well, we've got more information here. Well, based on the fact that we have the full equation, we know what a, we know what b is. We only have one unknown now, and it's the c. Isn't it true that all we have to do is take these guys, put them in here, and solve for that one unknown, which is c? That's the last thing. All we have to do is find that. So for the last part here, let's just simply substitute what we have. Now the clues are in the question, and the question does give us some pretty cool tools, and that is here we have x equals 1 and y equals 4. So there's our x. We can put that in there. There's x, and we can put the y equals 4 right over there, meaning we can find the c, because we already have the a and the b from over here. So let's put everything in there now. So let's go across over here. So the y equals 1. So let's work with the 1. So here's our x equals 1. So that's our y. So we're going to get 1 equals x cubed. What's our x? Well, we know what x is. X equals 1. No, y equals 4. Y equals 4. Let me just correct that. Y equals 4. So that 4 goes there. So 4 equals x cubed. Now what's x again? Our x is 1. So that's 1 cubed plus, and we have an a. We know what a is. A is negative 3. Negative 3 times x squared. Now what's our x again? It's 1. So that's 1 to the power of 2 plus bx. Now what's our b? B is negative 9. So let's go negative 9. Negative 9 times x. What's our x? That's 1 times 1 plus c. That's what we're looking for. So I'm going to put the c as a red. So that's plus c. We can just fit that in there. Let me just rub that out. So it's plus c. That's what we're after. Okay, let's further simplify this over here. So we have 4 equals 1 minus 3 minus 9, and that's negative 9 times 1 minus 9 plus c. So there's our plus c there. So let's start to work with this. 1 minus 3 minus 9, that's going to give us minus 12. Plus 1 is going to be minus 11. Minus 12 plus 1 is minus 11. So 4 equals minus 11 plus c. Let's further simplify. Let's add 11 to both sides. Plus 11 plus 11. 11 plus 4 is 15. So that means we have 15 equaling c. And there is our final variable. C equals 15. So our three variables in summary, I'll just write them up again in summary, is we have a equals minus 3, b equals negative 9, and C equals 15.